So you should have this written down. The DLO for today is I will learn how to graph quadratic equations in vertex form. Yesterday we learned about how A changed the graph, so how the coefficient of x squared changed the graph. A either stretched it vertically or stretched it horizontally. And you guys saw when we looked at Desmos yesterday that the graph was either getting very, very skinny or getting very, very wide. So stretching vertically would be getting skinny, and stretching horizontally would be getting wide. Who can remind me what if A was negative yesterday, if that coefficient of x squared was negative, what did it do to the graph? Good, good. It flipped it upside down. So if it was facing up like a U, it flipped it upside down. So it was like an upside down U. So A being negative flipped it upside down. Yesterday we also learned about a vertical shift. So when you added a number at the end, right, like a plus k at the end, it either moved the graph up or down. So if you added 3, for example, it moved the graph up 3 units. If you subtracted 2, for example, it moved the graph down 2 units. Today we are going to combine k, which is the vertical shift, and you guys can see that right here. So if you look over here, you see that k is right here. And this is the vertical shift, and we're going to add in a new piece of it today, which is h, all right? Now, who can tell me, what do you notice is in front of h? In front of h is an x, good. What's in between the x and the h? A negative sign, okay? That's very, very important, and here's why. The h is going to be our horizontal shift, so h is going to move the graph to the left and to the right. The problem is, or I shouldn't say a problem, just something that you have to remember, is that because there's a negative in front of it, what you have to do is you have to make sure that you account for that negative, and I'll show you what I mean in just a minute for that. But a lot of people get confused and they accidentally shift it the wrong way just because they forget about that negative there. So keep that in mind. This negative is going to play a part in where you shift the graph. So you should have this written down. Let's go ahead and move on so that we can do some examples. All right, so I need you guys to write this down for me. This tells you exactly what h does to the graph. So it says, if h is positive, and it says here it looks like x minus h. I'm going to explain that part in just a minute. But if h is positive, it will look like x minus h. And then the graph moves, that should say, oh, there you go, to the right h units. The graph moves to the right h units. If h is negative, it will look like x plus h, and then the graph moves to the left h units. So like I said, take a minute to copy this down, and then I'll explain what I mean by that. Good, it looks like most of you guys are almost done copying it down, so take about 30 more seconds if you're not done. All right, so here's what I mean by the negative part tricks you. Can you guys give me a positive number? Give me a positive number for h. 2, okay, positive 2. Look what happens if I plug in 2 for h. So look up here for me. If I plug in 2 for h, this is what happens. I get x minus, what did Makai just tell me that h was? 2, okay, x minus h equals 2. Does this look like a positive number? Does this look like a positive number right here? No, it looks like a negative 2, but don't get confused. The part that always confuses people is the fact that the equation itself has a negative in it, okay? Just because the equation has a negative in it doesn't mean that this is actually a negative number, all right? So we plugged in positive 2, but it looks like a negative number because the equation has a negative number in it. So please, please, please be careful. If h is positive, so Makai just told me that h was 2. If h is positive, like 2, it looks like this. It's going to look like a negative. It's going to look like x minus h. Then the graph moves to the right h units. With your finger, point to the right. Which direction is the right? Okay, good. It's this way. So it's moving this way, h units. All right? If you think about a graph, so let me pull up a graph really quick. If you think about a graph like this, and let's say that I just drew some x and y axes on it, okay? This direction, going in this direction over here, this is the positive x values. This is positive x values. And going in this direction over here, these are negative x values. So you guys all pointed, when I said point to the right, you guys all pointed this way, to the right, which is going in the positive direction. And Makai told me positive too, so that makes sense that it would go in the positive direction. But remember, and don't get thrown off by this, when you plug it into the formula, it's going to look like x minus 2. But the minus doesn't mean it goes in the negative direction. The minus is part of the formula. You actually plugged in a positive 2, which means it's moving in the positive direction too. Let's see what happens if I plug in a negative number. Can somebody else give me a negative number? Negative 4. Okay, good. So I'm going to plug in negative 4 for h. So I have x minus, remember that minus is part of the formula, negative 4. So I plug in a negative 4 for the h. What happens to minus a negative? What happens to that? It becomes a positive. So this changes to x plus 4. X plus 4. So that's what it means here when it says when h is negative, when you plug in a negative, it looks like x plus h. So it looks like x plus 4. But the graph moves to the left. With your finger, point to the left. Should be this way. Okay, good. It's moving this way. The left would be moving this way. If we pull up our little graph again, you can see that if I... Sorry, this won't be perfect. But if I draw my little x-axis, this is the positive x's over here. This is the negative x's over here. So if I'm moving to the left, I'm moving this direction, which makes sense because we plugged in a negative 4. You should be moving in the negative direction, even though your answer, the x plus h, will look positive. So please keep that in mind. It's always the opposite direction of what it says. If it says x plus 2, it really means shift it to the left 2, shift it to the negative side 2. If it says x minus 3, it really means shift it to the right 3, shift it to the positive side 3. So the middle term, what's inside here, is always going to be the opposite because the formula has that negative to begin with. So let me ask you one more thing before we move on to our first example. What do you guys notice? How could you tell the difference between the h and the k in a formula? How would you know which one's h and which one's supposed to be k? Good. H is the horizontal one, but if I gave you guys a formula, for example, if I wrote one down like x minus 3 squared plus 2, which of these is h? H is positive 3, okay? Why is h positive 3? Because it's the opposite. Remember that the formula is what takes the negative with it. So the negative came from the formula. H, I'm just looking for what the number is here. So h is positive 3, meaning you're shifting it to the right 3 in the positive direction. What would be k? 2. So here's my question. Here's what I meant earlier. Earlier I asked, how do you know which one's h and which one's k? So what if I told you this? What if I was sitting in this class and my teacher said, hey, and my teacher said, what value is k? And I told her, oh, k is 3. If I told her k is 3, who in here could tell me why I would be wrong? Why is k not 3? Because k is 2, but how do you know? Look at this. I want you to describe to me what you see in the formula that lets you know that k is 2. Why is k not 3? Because k is on the outside. Okay, that's good. K is on the outside of the parentheses. K is what's being added at the end or subtracted at the end. H is where? It's not on the outside. It's on the inside of the parentheses. So the horizontal shift comes from the inside. Moving it left and right comes from the inside. If you're adding a number on the outside, that's the vertical shift that shifts it up and down. All right? And we're going to see that today as well. So let's look at our first example. All right, write this down for me. Just like yesterday, I'm only going to make you draw the graph one time, so please draw this graph and draw it well. We have, I believe, 4 examples. We're going to plot them all on the same graph today. So draw this for me. I'll give you a minute. Good. Take about 30 more seconds. I see some of you guys drew pretty shabby graphs, but hopefully you can read them well. All right, let's do this first one together. Now, here's why, well, we'll do it with the t-chart first, with the x and y table first, and then I'm going to show you why I don't like the x and y table for this part, and I'll show you afterwards. What numbers did I tell you guys to fill in here yesterday?
0, -2, -1, 0, 1, 2.
Good. -2, -1, 0, 1, and 2. So we're going to plug these into the formula and see what happens, and I'll show you why I don't like doing it this way for this kind. So let's see. I'm going to plug them in down here. So y equals some number x plus 2 squared. All right. So the first number I'm going to plug in is -2. So that's this one here. I'm plugging in -2 right here. So I have -2 plus 2. What is -2 plus 2? 0. Those are opposites. Those are called additive inverses, opposites. So -2 plus 2 is 0. What's 0 squared, or 0 times itself? 0. So I'm going to fill in a 0 right here. This is -2, 0. All right, good. That was the first number. Now let me plug in the second number. So I have a -1. So what is -1 plus 2? 1. -1 plus 2 is 1. They're different signs, okay? So I subtract the numbers and keep the sign of the bigger number. So 2 minus 1 is 1, and then 2 is bigger, so I keep it a +1. And what is 1 squared? What happens when I multiply 1 times itself?
1.
Still 1. Good. So this becomes -1, 1. Now let me try 0. What is 0 plus 2?
2.
2. Good. And what is 2 squared?
4.
4. So this is 0, 4. By the way, the reason that we're adding inside of the parentheses first is because it's the order of operations. You have to do what's inside the parentheses first, and then you can raise it to the exponent. All right, let's try 1. Let's plug in 1. What do I get when I get 1 plus 2? 3. And what's 3 to the power of 2? 9. Good. And then last but not least, if I plug in 2 right here, I get 2 plus 2. What's that? 4. And what's 4 to the power of 2? 16. 4 squared is 16, because 4 times 4 is 16. So I know it's not going to fit on the graph perfectly, but do me a favor and plot as many of these points as you can. So -2, 0. -1, 1. So it goes -1 in the x direction and +1 in the y direction. 0, 4. 1, 9. And then the last one's going to go off the graph. Now, if I connected these, does this look like the graphs we were looking at yesterday? Does this look like a parabola?
No.
Not really. I would connect them and they would kind of look like that, and then you don't really know what to do after that. Also, yesterday, every single time we did these yesterday, these ones always matched up and these ones always matched up because our parabola was symmetrical. Okay? Let's see if you guys could tell me, if anybody in here could tell me, who can tell me why that doesn't work when you choose these numbers today? -2, -1, 0, 1, and 2. Why would that not work out today?
Because they're not,
Good. Number one, they're not symmetrical. Who can tell me from the equation, what is this positive 2 doing to the graph? But remember we talked about earlier that it's a shift?
Yeah.
Shifting it where?
Shifting to the right.
I hear to the right. To the right would be in the positive direction, correct? But it's not supposed to be positive. Remember, it's the opposite. So this is like, I'm going to rewrite it for you so you guys can see. Remember that it's a positive, but the equation originally had a negative there, so it's minus a negative 2. So it's not shifting it to the right, it's not shifting it in the positive direction, it's actually shifting it in the negative direction too. So yesterday we talked about the axis of symmetry. Remember the axis of symmetry cut the parabola right in half so that it was symmetrical on both sides. If you shift the graph, then the axis of symmetry shifts with it. So if you shift the graph 2 units to the left, sorry, this line's not going to be perfect, but you'll get the point. If you shift the graph 2 units to the left, the axis of symmetry is going to shift 2 units to the left as well. So notice that that is the new axis of symmetry. Everything should be symmetrical on both sides. So let's do this. Let's take some points and let's reflect them. So notice that I'm reflecting this one across the axis of symmetry over here. I'm going to take this one and reflect it across the axis of symmetry over here. I'm going to take this one up here and I'm going to reflect it across the axis of symmetry over here. And now, if you connect those points, it looks like a parabola from yesterday. And it looks exactly like the same one we did yesterday, just shifted to the left 2 units. Because remember, it's the opposite, so it's shifting in the negative direction. Now, this is why I don't like plugging things in a T-chart, because you guys like choosing these numbers, -2, -1, 0, 1, and 2. But if you do that, it doesn't give you a very balanced picture of what the parabola looks like. It only gives you 1/2 of it. So in addition to making this T-chart, you also have to figure out where the axis of symmetry went so that you can reflect points across it in order to make sure you're getting the correct picture. Personally, for me, remember yesterday how I told you guys to remember those numbers of the very first graph? I told you there was one graph that was the most important one. It was -2. What was -2? All right, good. It looks like you guys are really awake. So do me a favor, open up your notes from yesterday and look at the very, very first example we did yesterday. The very, very first example we did yesterday was y equals x squared. And we made a little t-chart for it. We made a little xy chart. Okay, we plugged in these numbers, -2, -1, 0, 1, and 2. What went with -2? What was next to it? I heard a couple people whisper it. What was next to it? 4. What was next to -1? 1. What was next to 0? What was next to 1? And what was next to 2? Okay? Those are the most important numbers that you can remember if you like to do it this way. Of course, I'm not going to force you to do it this way, but in my opinion, it's so much easier if you can remember those numbers. The rest of it comes so much easier. For example, all right, all you have to do is take these points, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. And if you know that the graph is shifting 2 units to the left, all you do is you take them and you move them all 2 units to the left. So notice that this point here, if I move it, if it was originally right here, so I'll kind of point so you guys can see, this is 0, 0. That was the original point on the graph. Notice that I just moved it 2 units to the left and it came right here. In green, this was the point 1, 1 from the original graph. I moved it 2 units to the left and it became that one. In purple, this was the point 2, 4 on the original graph. I moved it 2 units to the left and it became this one. All right? So in my opinion, it's easier to draw the original graph and then just shift it from there rather than using this table of values, because I think the table of values doesn't always give you an easy, nice picture. So on the next example, we're going to practice doing what I just said rather than creating a table of values. So write this one down for me. And don't worry about writing down the table of values, because I don't want to do that one this time. We'll come back to it later. So, y equals x minus 3 squared. Here's what I'm going to do. You guys don't have to do this on your paper, but I'm going to plot the original function. Remember, the original function went through 0, 0, 1, 1, 2, 4, negative 1, 1, and negative 2, 4. If you can memorize that graph, you can figure out the rest of them super, super easily. That's the one graph I told you yesterday that you need to memorize, and the rest of them should come pretty easily. From here, who can tell me what this negative 3 is doing to the graph? Shifting it. Okay, it's shifting it where? Vertically or horizontally? It's shifting it horizontally, so it's shifting it left and right. How many units is it shifting it? 3 units, because there's a 3 right there. And it's negative, so point with your finger, point which direction it's going to move. Negative, remember it's opposite because of the formula. So negative means it moves in the positive direction. Because if I write it like this, I get x minus a positive 3 squared. So it's moving it in the positive direction. So on your graph, you're going to plot this in just a minute, but look up here with me first. If I do it in purple, can you guys see purple? I hope so. If not, just let me know, please. Okay, here's what I would do. I know it's shifting it 3 units, and I know it's shifting it in the positive direction, and I know that this black dots, the black dots that I just drew are the original graph. So everybody look up here for me. All right. See this point right here? I'm going to shift it 3 units in the positive direction. 1, 2, 3. And I'm going to put a new point right there. All right. See this point right here? I'm going to shift it 3 units in the positive direction. 1, 2, 3. And I'm going to put a new point right there. Same thing with this one over here. I'm going to shift it 3 units in the positive direction. 1, 2, 3. I'm going to put a new point right there. And I'm going to do that with the other points as well. So this one I'm going to shift 1, 2, 3. And a new point goes right here. And this one I'm going to shift 1, 2, 3. And a new point goes right here. And look what happens now when I connect all these purple dots. I get my parabola shifted 3 units to the right. So on your paper, I want you guys to plot these new points. This is the point 1, 4. This is the point 2, 1, 3, 0, 4, 1, and 5, 4. So plot those for me on your graph. Yes?
Does this method always work?
Yes. If you can recognize which one's a vertical shift, which one's a horizontal shift, which one's a vertical stretch, a vertical shrink, or a horizontal shrink or stretch, then it will always work to graph them this way. Now, the ones we're doing today are very, very baby steps. When we come back tomorrow, we're going to put all of these together. So we're going to put A and H and K, and we're going to do all of them together on one graph. Today, we're just doing little tiny baby steps. All right, we're going to do one more example together, and then the last one I'm going to have you guys do on your own. And in the time we have left in the period, I'm going to let you guys work on your homework. We only have 5 questions for homework tonight, so I think you guys could probably finish it before the period is over today. After we're done. All right, here's the next one we're going to look at. So write this one down. Again, we're not going to use the table. I don't want to use the table for these. I think it's easier without the table. So don't even worry about that. All right, so here's what I want you to do for just a minute. Notice that there are 2 numbers in this one. Okay, I want you to talk to your partner for just a minute, and then I'm going to call on somebody to tell me. I want you to talk to your partner about what you think the 1 does to the graph, like shifting it where and which direction and how many units, and what the 3 does to the graph. So talk to your partner for 30 seconds. I'm going to call on somebody. All right, here we go. I guess that's too big, huh? All right, so here's what I'm going to do. I'm going to plot the original graph in black. So it went through 0, 0, 1, 1, negative 1, 1, 2, 4, and negative 2, 4. So this is what the original graph looked like, okay? That's the one I keep telling you. If you can memorize that one graph, you can figure out all of them. So let me see if you guys talk to your partner about what these things do. Nick, what does this negative 3 do to the graph? Not quite. Who can help out Nick? What does this negative 3 do to the graph? I hear it moves it to the left. Not quite. It goes down. How do I know that this is a going down one, not a horizontal shift? It's negative, but what else? Good, it's on the outside. Notice that the negative 3 is on the outside of the parentheses. That means it's a vertical shift. It shifts it up and down if it's on the outside of the parentheses. All right, so negative 3 is going to shift it down 3 units. So on your paper as well, if you have a different color, it would be helpful in a different color. If not, it's okay if you do it in the same color. But I'm going to move everything down 3 units. So I'm going to move this down, move this point down 1, 2, 3. And I'm going to put it right here. I'm going to move this point down 1, 2, 3. I'm going to put it right here. Same thing with this point and same thing with these points. Now, my purple graph is not the final answer yet. All that did was a vertical shift down 3. That's like an intermediate answer. I have one more shift to do. I need to figure out what this 1 does to my graph. So, let's see. Joel, can you tell me what the 1 does to my graph? I hear it goes left how many units? 1 unit. Okay. The 1 is inside of the parentheses, so that means it's a horizontal shift. And the fact that it's a 1 means that it's 1 unit to the left because it goes in the negative direction. So I'm going to take in red, I'm going to do these. This is my final picture. So I'm going to take this point and move it 1 unit to the left in the negative direction. Who can tell me why I'm moving it in the negative direction again? Because it's the opposite. Good. If I look at this, it's x minus a negative 1, which means it's moving to the negative direction 1. So I move all of these points in the negative direction 1 unit. So I moved this one here, I moved this purple one right here, I moved this purple one right here to the left 1 unit, and this one right here, and this vertex, I moved it down here. So now if I connect these points, the red graph is my final answer after I shifted it a bunch of times. So this is the final answer. So on your paper as well, write that down. Final answer. So this one had 2 shifts. It had a vertical shift down 3. That's the purple graph. And it also had a horizontal shift to the left 1. That's the red graph. All right. At the beginning, the title for today, it was, I will learn how to graph quadratic equations in vertex form. All right. This is called vertex form because it tells you essentially where the vertex is. So notice here my vertex was at 0, 0. I moved it down 3 into the left 1. And now my vertex is at negative 1, negative 3. Can you guys see how you might get negative 1, negative 3 from this form up here? Where do you see the 1? Here's the negative 1, and then the negative 3 comes from the outside. So the negative 1 comes from here, and the negative 3 comes from right here. That's why this is called vertex form, because it tells you where the vertex is located. So here was the vertex here, shifted it down 3 and to the left 1. So now it's at negative 1, negative 3, which comes from right here. All right, I'm going to give you guys one to try. Now, before I give you guys that one, if you like the t-chart better, the x and the y chart better, that's fine. You can use that. But the thing you need to be careful about is that you need to know where the axis of symmetry is so that you can correctly reflect all the points across it. So you can either do it this way, by shifting it, or you can do it using the x and y chart. Just make sure that you graph the graph correctly. So I'm going to give you guys a few minutes to do this one.
When I plugged in -2, I got 36. It's still,
Mm-hmm. That's why I don't like doing it that way.
I was like, oh.
So if you want to, like, you could change these values to plug in instead. So do you
4.
know where the axis of symmetry is going to be?
No.
What does this graph? What does the 4 do to it?
It's to the right.
Correct. Okay, so maybe instead of choosing values centered around 0, you want to choose values centered around +4 since it's going to move to the right 4. So maybe choose 4 as the center point, then go up 2 and down 2.
Oh, okay.
That'll give you some better points. If you guys are stuck about how to start this, I was just talking to Brian about a good idea. First of all, let's come back to Nick. Let's see if you can redeem yourself. Nick, what does this +1 do to it? Up 1. Okay, good. This +1 moves it up 1. Who can tell me what this -4 does to it?
Moves it to the right.
Moves it to the right. Okay, it moves it to the right because it's a negative. So remember, it's like x minus a +4. So that's why I'm moving it to the right 4. He says that he likes the graph better. He likes the t-chart better, making the xy table, and that's fine. My hint to you guys is if you want to do it, because he plugged in our normal values. He plugged in -2. This is wrong, by the way, so don't write it down. -2, -1, 0, 1, and 2. And he noticed that if you plug in -2, automatically you get a huge number, right? -2 minus 4 is -6. Squared would be 36, plus 1 would be 37. That's a gigantic number and probably won't help you at all. So what I suggested to him was, if you like this little xy table, okay, if you like it and you actually want to use it, that's fine. But instead of choosing -2, -1, 0, 1, and 2, choose values centered around where the axis of symmetry is. And the axis of symmetry is right here at +4. So I would make 4 your middle number, then go up 2 from that, so 5 and 6, and go down 2 from that, so 3 and 2. If you make that the axis of symmetry, if you make that your middle number, then you won't get huge, huge numbers or really, really small numbers. You'll get normal size numbers. So if you like the XY chart, do it like this instead. Figure out where the axis of symmetry is and make that your middle number, and that way you'll get even numbers on both sides. So go ahead and keep going. We'll go over the answer in just a minute. All right, so it looks like most of you guys have something written on your paper, so let's go ahead and look at this answer together. Up here in black, I drew the original function, the one that I think that it's important to know by memory. It goes through 0, 0, 1, 1, -1, 1, 2, 4, and -2, 4. This is the most important graph you guys are going to learn about when we talk about quadratic functions, because it's the parent function. It's like the main one that you could base everything else off of. So in the way that I like to do it, we're going to do the way I like to do it first, because I think it's faster, I think it's more efficient. So we're going to do that way first, and we're going to check it using the t-chart. So you guys told me that it shifts in the positive direction to the right 4 units. So on purple, I'm going to shift it to the right 4 units. So 1, 2, 3, 4 gives me right here. 1, 2, 3, 4 is right here. I'm not going to draw those little waves every time because you guys get the point. But 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And then these ones as well, right here. And 1, 2, 3, 4. That one happens to land on top of the other one. So that would be the purple one. That's not the final answer yet. That's still an intermediate one. That was just the horizontal shift. And then plus 1 moves it up 1. So it goes up here, up here, up here, here, and here. So that red one is the final answer. So yours should look something like that. Now personally, that's my favorite way of doing it because I think it's fast and I think it's efficient. You have to kind of graph the graphs a lot and you have to make sure you notate which one's the final answer, but I think that's the fastest way to do it. Let's check, if you had done the chart instead, let's check to make sure you get the right answers. Here we go, 2. If you plug in 2 up here, what's 2 minus 4?
-2.
-2, and what's -2 squared, or -2 times -2? 4, and then 4 plus 1 is 5. So that should be the point 2 comma 5. If I look at my graph over here, 1, 2, and then up 1, 2, 3, 4, 5, notice that I have that red point on my graph, so I got that one right. If I plug in 3, what's 3 minus 4? -1, what's -1 squared? 1, and then 1 plus 1 is 2, so I should have it at 3 comma 2, and if I look at my graph, I have the point 1, 2, 3, comma 2, so that red point is also there. At 4, what's 4 minus 4? 0, so 0 squared is still 0, and plus 1, that would be 1. So this should be the point 4, comma 1, which I have right here on my red graph. Notice that it's symmetrical, so this should also be a 2, and this should also be a 5. Okay? So you need to make a decision, because we're about to start on our homework. You need to make a decision. You have 2 options for this decision. Option number 1, you like doing this chart better. Okay? You like doing this chart better, and you want to fill in this chart to graph. That's totally fine. The only thing you need to be careful of is that you account for where the axis of symmetry shifted to, so that you put your numbers around the axis of symmetry instead of around 0, because it won't help you around 0. Option number 2, if you like doing it this way better, where you draw the original graph and then just shift it from where it needs to be. Alright, that's option number 2. You can do it that way as well. I want you guys to work on your homework individually for the first 5 to 10 minutes, so I don't want to hear any talking for the first 5 to 10 minutes. Your homework is page 2 in your packet. There's only 5 problems on page 2. Alright, so please get started on those.